Hi everyone. Today we will discuss hashing algorithm or construction of the hash table. It's an efficient method to store and access the elements. Hashing algorithm actually improves searching of performance just like we will take now. Let's take main method. Fixed title. Now I will take in the global size of an array. I will take array. That is, I have taken an array of size 5. That is, initially it will store 0, 0, 0, 0 values. Now I will add constructor for that. Constructor, I will make everything as -1. That is array of each is -1. Now I will create an object for the class hash table. So constructor will call equals to hash table. So I will print now. I will print now this array public void for int I equals to 0, I is less than size I plus plus, and I'm printing that error of I print here now object dot print. Now I'll take so -1 so everyone initiate like -1. I will take 0 index, so 1 index, 2 index, 3 index, 4 index, so size is 5. So and it is -1, it is -1, is -1. Actually the -1 represents whether the array is empty or not. So like this. Now I will simply construct the hash table. Like I will construct means just like I will construct now. I will take public set value. Now we'll take int key equals is equal to value itself. That I will tell you now. And array of index index is equal to key. So array of index equals to value. I'm directly adding values. Oh, this thing we have 0. Now we have the -1 minus values, right? If I want to add a 0 element, that is what I'm doing here is nothing but simply uh, f of x equals to x. If I want to add a 0 element, I will add in a 0 index. One element is one index, two element is two index, three element is three index, like that. So I will simply add object dot insert one. I will add. So after adding, you can see it is -1 coming in the one index. I have added one. So if I want one index, I will simply it is just like the key and value system. Actually this key hashing algorithm, here it's improves the switching performance, just like f(x equals to x equals to key. So this key and value actually and helps us understanding the internal working of the hash map, which we will discuss in the future class Java corrections. So what is the drawback here means, if I want to add f of x equal f of 100, then I can take simply 100 size array, and I can add the value at the key 100. But before the, for example, if it is 100, the elements we other elements are only 4. So in 4 to 100, the most of the space is wasted, so it is not the efficient for space complexity. So for that, I am simply what I'm going to do, I'm using modular operator. So what I'm going to do is, I will simply take modular operator, that is uh, here any number. To take any number, that is mod modular divided by n, that will gives to 0 to n minus 1. That is, if you take any number, any value, for example, if you take 3, the 3, the n is represents the size. So any number, if it is 0 modulo is, it will gives 0, and 1 modulo 3. Modulo modulo operator will gives the remainder. So 1 modulo 3, it will gives 1, 2 modulo 3, it gives 2, 3 modulo 3, it gives 0. That is it will repeat 0 to 1, 2. That is when it is 3, again the remainder is 0, again 4 means remainder 1, again 5 means remainder 2. So it will just oscillate from 0 to 2, that is 0 to n minus 1. So that is the advantage of the modular operator that we will use here. We will simply we will take as here in the code, in the insert function. So instead of f of x, I will take uh, f of x equals to x. Instead of that, I will simply take int key is equal to value modulo size, and so that is I'm just taking some key is equal to x value, but with that way I'm taking modulo of that size. So like that I'm taking here. Now just observe the code here. While array of index is not is equal to -1, uh, then we will simply do index equals to, for example, if I added one element which is a 0, suppose I will add here some element like uh, it is 5, size is 5, so 10. 10 modulo n will give 0. If I want to add some 15, 30 also, it will use modulo reminder 0. So if it is the collision is there, the same element is coming again. This is called the collision, hashing collision. So we will do the linear probing. We will just add that is we will just add to index plus 1. We'll just shift to that other index available, and modulo uh, size. And if it should not be again, if come it will come if it comes to again the same, suppose there is no space at all, means if index is again equals to key, means we will simply do, we will simply return, because it is space is full already here. Then then uh, then array of index, if it is not like that, then we will take that value in that index, and we will simply return. So this is a code. Now I will take some values so you can understand better. uh, Object dot insert, I will take 10. Then I will take 15. I will take 2. Like that I will take, then after I will print it. So you can observe here, it is using 10, 15, 2, because we have inserted the 10, 15, 2, and -1, -1. Actually 15 mod 5, it will use reminder 0, but it just already 10 is there, so it is just shifted the right side. So what I have written the code, index plus 1. So this is called the linear probing in hashing. So now uh, so now I will construct similarly. Now I will construct the delete function. So delete function also follows the same code. I can simply take this code, and now I will take this code as delete, and now just simple modifications here. Already the value is there, right? So I will taking value, and so deleting, so I will just simply make that is as -1. So if I want to make delete element 15, let's suppose object dot delete. I want to delete 2. So after deleting again, I will print the value. So you can see on the console object dot print. So so first it is 10, 15, 2 minus 1 1 we are inserted. So after I deleted 2, so it is minus 1 again. We make that as a empty space. Now I will do the search operation. Even the search operation is also quite similar, same code. Also for search, uh, I'm taking here search SEA or CH search into value, and then so uh, if index equals to key here itself, we will print uh, search not found, and here instead of this making anything, we'll simply, or else we'll do here search search found. So now I will do object dot search. I will search 10, and after that I will do search object dot search the element which is not there. That is, let's take element 1 3. This element is not there, so let's see that. So yeah, the last element is not found. So first is showing. So here first I will inserted 10, 15, 2 minus 1 minus 1, and then I deleted the 2, so I make it a minus 1. Then I search for 10 element, it is there, so search is found. So then I search for element which is not there, so search is not found. So this is the about hash table constructing, inserting, printing, deleting, searching, everything. So what is the use of the hash table is, for example, if you have the problem, there is an to solve the problem, let's it check whether if an array is a subset of any other array. So you will for example, you will get one array, like you will get one array with elements 1 2 3 4, and you will get array 2, array 2 1 2 3. So if you check if whether array 2 is a subset of array, yeah, it is subset of array. So you have to check if it is subset of array or not. Then you will simply do like, you will just first insert array 1 elements in the hash table. Then you will simply search the array 2 elements in the hash table, inserted 1 2 3 4. So it will be found. So what is the use of the hashing is, it is useful for searching optimization. It is almost it is a order of 1 we will get big O of n, which is the best time complexity for searching operations. And also you can see that hashing is also principle which helps for understanding cryptography, blockchain technology, cryptocurrency there in the also in the future videos we'll discuss Java collections where we will use hashing internal structure in the hash maps. And some other problems like whether check two arrays or disjoint or not. The same thing we will do, and check whether if the check for some sub array with some equals 0, like there are many of problems you can use this hash table. So you can simply uh, pause the video from here to here. You can simply pause the video, and you can check for the code whether if you not understand of anything, it's overall code. So this is all about hashing algorithm.